So there are a few things that we also need to talk about. So remember back when we did equations and we would solve it, and we had 3 different solution types. Well, the same happens for systems of equations. If it doesn't equal, then it's no solution. If they're the exact same, then it's infinitely many solutions. So let's look at number 13 for number 1 for substitution. So I'm going to solve for this y to get y by itself. Okay? So I'm going to add x to both sides. So I get y equals x plus 3, or 3 plus x, either one. So remember, I'm going to substitute this x plus 3 in for this y right here. Okay? So that gives me negative 3x plus 3 times my x plus 3, because that's what y is, equals 4. Alright? Now I just need to solve for x. Negative 3x, 3 times x is positive 3x, 3 times 3 is positive 9 equals 4. Now I can find my like terms. Negative 3x plus 3x is 0x, right? So those go away. Then I'm left with 9 equals 4. Well, does 9 equal 4? No. That means this is a no solution. All right, we're going to look at what that means on a graph next. Okay? Also, if you get this, and this is, say, 9 equals 9, then it's obviously infinitely many solutions, just like what we talked about when we did equations. So let's talk about graphing. So with graphing, let's look at this one. So first things first, I have to solve for y in order to graph it. It's kind of a pain, but at every turn, if you don't know what to do with solving systems of equations, solve for y and put them in your graphing calculator. And when you graph it, just find where they intersect. And that's all you need to do. Okay? So let's look at the first one. So I need to get y by itself. So that means I have negative 2x minus y equals 1. So I'm going to add 2x on both sides. So I get negative y equals 2x plus 1. I need to divide by a negative 1. So that's my coefficient. So y equals 2 divided by negative 1 is negative 2x. 1 divided by negative 1 is negative x. So there's one equation. Now let's do the second one. So negative 6x plus, equals 3y plus 3. So first things first, I need to solve for y, so I'm going to subtract 3 on both sides. I get negative 6x minus 3 equals 3y. Divide by my coefficient of 3. Negative 6 divided by 3 is negative 2. X. Negative 3 divided by 3 is negative 1 equals y. So there's my other equation. What do you notice about these two equations? This says y equals negative 2x minus 1, and this says negative 2x minus 1 equals y. What do you notice? They're the same, aren't they? They look like it to me, but let's make sure and let's graph it. So let's graph this first one. My y-intercept is negative 1. My slope is negative 2 over 1, so I'm going to go up 2 over 1. Down 2 over 1. So there are my points. So I'm going to draw my line. So there is that equation. Now let's go to the next one. Negative 1 is my y-intercept. And then negative 2 is my slope. So go down to, wait, doesn't this give me the same line? Well, if it's the exact same line, that means it intersects every single place on this graph. Therefore, this system would have infinitely many solutions. They intersect everywhere. They're the exact same. If they're the same, they have infinitely many solutions. Okay? So let's look at this one. So, on this one, we first have to solve for y again. So, I'm going to solve this first one for y. So x minus 2y plus 8 equals 0. So I'm going to subtract 8 first. I get x minus 2y equals negative 8. I'm going to subtract x on both sides. Remember, I want y by itself. Negative 2y equals negative x minus 8. I need to divide by negative 2. So y equals negative 1 divided by negative 2 is positive 1/2 x. Negative 8 divided by negative 2 is positive 4. So there's one equation. All right, now let's do the second one. Negative 6 minus 2y equals negative 8x. Want to get y by itself, so I'm going to add 6 on both sides. Negative 2y equals negative x plus 6. Divide by negative 2. I get y equals positive 1/2 x minus 3. Negative 1 divided by negative 2 is positive 1/2. 6 divided by negative 2 is negative 3. Now, when you look at these two equations, what do you notice? Well, I notice that my slopes are the same, right? But my y-intercepts are different. So let's graph them. Let's graph this first one. So my y-intercept is positive 4. My slope is 1/2. Over, down 1, over 2. Make sure it's positive. Down 1, over 2. So here's my first line. All right. Then let's graph the second one. Negative 3 is my y-intercept, and then 1, 2, up 1, over 2. And here's my other line. What do these look like to you? They're parallel. They're parallel lines, and parallel lines have no solution. I call this the friend zone, right? You're in the friend zone, you're never going to happen, okay? So these things are never, if they're parallel, they'll never intersect. So that's what's no solutions. So that's kind of the gist. So some things to remember would be one solution looks like this. It has a point and an x and a y. That is my solution. Okay? No solution. They're parallel lines. They have something like when you solve, it has like 3 doesn't equal 8. Something like that. Like when you solve the equation, there's nothing there. Okay? And then infinitely many solutions are the same line. Okay? So what these equations look like when they're in slope-intercept form, this would look like, this would have the same slope, but different b, right? Your y-intercept. Okay? Infinitely many has the same equation, which means they have the same slope and the same y-intercept. Okay? So hopefully that kind of makes sense. Oh, and with infinitely many solutions, that's where like 4 equals 4 when we solve. Okay? Remember, use your knowledge about equations to apply to systems. Alright? It's nothing new. Once again, if you have questions, leave it on my discussion board.